Hello everyone, welcome back to another video. Today we are going to be doing something more fun and hopefully you're going to be learning a lot from this small project. What we're going to be creating is a script that generates random clouds with random scales and random locations using meshes and volumes. Additionally, we'll have an awesome looking properties panel that you can mess around with and change in real time. So without further ado, let's go ahead and get going. So before we do anything, make sure you go over to the edit menu, go to preferences, go over to interface and make sure that Python tooltips and developer extras are both enabled and make sure you save preferences. So we'll close this out. And what we're going to do right now is we're going to head over to the scripting tab, which we can do by clicking on it. And we're going to go ahead and hit new. Make sure word wrapping is on. It's this icon right here on the top right. And we will also be making sure that our syntax highlighting is turned on. So now we're ready to begin. So usually I would write the code and explain it along, but I think that since there's so much going on, I think it would just be better to structure the video into a part in which I swiftly guide you through the process of coding it out, and then provide a quick in-depth explanation of all these lines of code once we're finished. This should help us optimize time and shorten the length of this tutorial, which is already expected to be longer than usual. The first step is to define our BL_info dictionary. So if you don't know what a dictionary is, it's basically a set of keys and values separated by commas, and they're a very useful Python data structure. So we're going to type in BL_info and then equals and then open curly braces, and then we're going to hit enter a few more times to make some space, and then we're going to close the curly braces. So we could manually type our entire BL_info out, but I think that might take a bit of time, and I think it might actually be better to go over here to templates, Python, Addon, add object, and you see how there's like a pre-made BL_info. So we're going to go ahead and copy the contents of it all the way over to category, copy, head back over to our text, and we're going to paste it in. You see there's a little bit of a wrong indentation here, so we can just hit tab to make sure everything is properly indented and make sure we get rid of the spaces. So now we basically just change these values to whatever our add-on is going to be. So in this case, the name of our add-on is going to be Cloud Gen with this uppercase C and G. The author is literally just your name, so I'm just going to put mine there. For version, you can leave that at 1,0. And for Blender, this is the Blender version. So if you don't know your Blender version, you can literally just go down here and see mine is 3.4.1, which is the latest Blender version. But in your case, it could be different. So if you don't know your Blender version, you can check it out on the very bottom right of your screen. For location, we can type in View3D, and then we can say N, because our add-on is going to be located on the in panel. And let me just real quick change this Blender to 3, 4, 1 for 3.4.1. Description, it's literally just the description of your add-on, so we can change this to generates randomly scaled and randomly located clouds. For warning and doc_URL, we're not really going to need to type anything because we don't really have any. And for category, we can leave this at add mesh. If you don't know what category to use on your add-on, you can literally just go to edit, preferences, and then to the add-ons tab, and then you see this list that says all. Just click on it to expand it, and you'll have like all the categories that you can use. So yeah, we're going to go ahead and close this preferences, and that's pretty much it. We're going to hit enter a few times, and we're going to type in import BPY, then import bmesh from bpy.props, import asterisk, meaning everything, and lastly we're going to import random. So as I said, we're going to swiftly code this all out, and then once we're done, I'm going to explain everything in more detail. So that way we optimize time, as I said. So don't worry if you're confused about what certain line of code means. Once we're done, I'm going to be explaining all of that in more detail. So we're going to have 3 classes. One for the properties, another one for the UI panel, and another one for the operator, which is the generate button. So let's start off with our properties class, which is basically going to be a couple simple float and float vector properties. We're going to be having access to changing 3 properties, but of course you can use the knowledge you gain in this video to further expand into creating more properties for tons of different customization options that fit your specific needs. So first let's go ahead and type in class, and then cloud gen props with uppercase C, G, and P, which is known as camel casing, which means for each word just make it capitalized. And inside of these open and close parentheses, we're going to type in bpy.types.property group. with uppercase P and G, meaning this is a property group. So then we're going to type in colon, and then we're going to hit enter a few times, and firstly we're going to say density, and then colon, space colon, and then float property with uppercase F and P. So now we're going to type open quotations, and then we're going to hit enter, and we're going to hit tab to indent. So the first thing we're going to do is we're going to type in name is equal to, in quotations, density, and then we're going to type in comma, and then we're going to say description is equal to density value of the volume, and then comma, and then lastly let's say default is equal to 3.0. So now we'll add one more line, and it's going to be update is equal to update underscore density. Now this is going to be a reference for a function that we haven't created yet, and we probably won't until the end, so you don't really need to worry about that. Go ahead and close the parentheses, and now we can enter and unindent. So let's go ahead and type anisotropy colon float property, just like we did with before, and open parentheses, and then enter, and then tab to indent. And we're going to type in name is equal to, in quotations, anisotropy, and then comma, and then description is equal to anisotropic value of the volume, and then comma, and then we can say default is equal to 0.075, then comma, and then update equals update underscore anisotropy, or however you pronounce that. Once again, this is going to be a function that we'll create towards the end of this video, so no need to worry about that. And then close parentheses, and then enter, and then shift tab to unindent. And now for the last property, we're going to type in color colon float vector property, because it's going to hold multiple float values. Hit space, and then enter, and then tab to indent. So what we're going to type here is name is equal to, quotations, color, and then comma, description is equal to changes color of the active volume, and then comma again. Then we're going to type in default is equal to open and close parentheses, and inside of these parentheses we're going to type in 1.0, comma 1.0, comma 1.0, comma 1.0. So 4 values there. So then comma, and then enter. And now we're going to type in subtype is equal to, in single quotes, color in all caps, and then comma. And now we're going to type in min is equal to 0.0, and then comma, and then mats is equal to 1.0, and then comma. And then lastly, we're going to say size is equal to 4. And then once again, we're going to hit comma and say update is equal to update underscore color. So we're going to go ahead and close parentheses, and we're going to hit enter a few more times. We're going to hit shift tab a few times to unindent. So now let's go ahead and define our UI panel class by typing class, then cloud gen with uppercase C and G underscore PT with uppercase P and T underscore cloud underscore panel. And then open and close parentheses, and inside the parentheses we're going to type in bpy.types.panel because it is a panel. And then after the parentheses we're going to type in colon and then enter. And the first thing we're going to be typing is bl underscore label is equal to, and then in double quotations, cloud panel. And then we can type in bl underscore id name is equal to, we can say in double quotations, cloud gen underscore pt underscore cloud underscore panel, which is basically the same as the name. And then we can say bl underscore space underscore type is equal to view underscore 3D in all caps and in double quotation. Then we're going to define our bl underscore region underscore type equals in double quotations UI. And lastly, we're going to say bl underscore category is equal to, and we can say cloud gen with uppercase C and G, which is how it's going to show up on our AMP panel. So now let's hit enter a few more times for spacing, and we're going to say df draw open and close parentheses, and inside the parentheses we're going to type in self and then contents and then colon. So this is the drop function, which is going to draw all the elements on our UI. So now we can type in layout is equal to self.layout and then enter. And then we can type in row is equal to layout.row with open and close parentheses. We're going to hit enter and type in row.label, open and close parentheses, and we're going to say text is equal to maybe add cloud. We're going to make a new row, so we're going to go ahead and copy this row equals layout.row code, paste it there, and then hit enter again. Finally, we're going to type in row.operator and then open and close parentheses, but we're not going to put anything inside the open and close parentheses yet, as we don't have an operator defined, but we're going to come back to this later and fill it out. And by default, after you hit enter, after a colon, it should auto indent. And enter a few more times and then shift tab a few times to unindent. Type in class cloud gen and then underscore ot underscore cloud underscore add. So now we can hit open and close parentheses and now type in bpy.types.operator. So it's similar to the one we did up here, but instead it's an operator type. We can type in colon after the parentheses, and now we're going to hit enter. And we're going to type out a doc string for our tooltip with triple quotes. And inside them, we're going to say, so triple quotes first, and then we're going to type in adds clouds at random location and random size. Alright, then enter, and we can say bl underscore label is equal to generate in double quotes, and this is going to be like the label on the button. And then bl underscore id name is equal to, then we can say cloud underscore add. And lastly, we can say bl underscore options is equal to open and close curly braces, and inside of the curly braces, we're going to type in double single quotations, register, and then comma, and then single quotes again, undo. This is going to let us perform undo and then redo operations with our operator. So let's hit enter a few more times, and we're going to type out def execute, open and close parentheses, and then we're going to say self, and then context, and then a colon at the end of it. So this is going to be our execute function, and everything inside the indentation level of this execute function, so in this indentation level, is going to get executed once this operator gets called in our button. So the first thing we're going to type out is bpy.ops.mesh.primitive underscore cube underscore add. So open and close parentheses, and this is going to add a cube. So we can type out a comment here using the hash key saying add cube. So we're going to be using comments throughout our code to help us understand what's going on with our lines of code. Let's hit enter a few more times, and we're basically going to say obj is equal to bpy.context.active underscore object, meaning this is the active object, and then bpy.ops.object.editMode underscore toggle, and then open and close parentheses. We're going to type in a comment that says we're assigning a variable to the active object. So just for the sake of not spending too much time adding comments and stuff, we're going to add them later once we're explaining everything that's going on. So now we are going to type in em is equal to bmesh.from underscore edit underscore mesh, and then open and close parentheses. Inside the parentheses, we're going to type in obj.data, meaning it's going to grab the active object data. And then we can say enter and bm dot faces dot ensure underscore lookup underscore table, and then open and close parentheses, which is basically going to make sure our indexing works fine. So now we're going to type in for face and bm dot faces, and we can say colon and then enter. We can say face dot select underscore set, and then open and close parentheses, and inside of the open and close parentheses, we're going to type in false with uppercase F. So now we're going to hit enter a few more times, type in bm.faces, and then open and close brackets. Inside the open and close brackets, we're going to type in 0, and then we're going to type in dot select underscore set, and then open and close parentheses, and inside of the open and close parentheses, we're going to type in true. And we can essentially just copy this line, and then just paste it 2 more times. So now basically what we do is on the second line, just change this indents to 2 inside the brackets, and in the third line we'll do the same thing, but we'll change it to 4. So now we'll go down here and we're basically going to say bmesh dot update underscore edit underscore mesh, open and close parentheses. Inside of the parentheses we're going to type in obj.data. Now let's hit enter a few more times, and we're going to type in bpy.ops.mesh mesh dot extrude underscore faces underscore move, and then open parentheses and enter and tab to indent. And now we can say mesh underscore ot underscore extrude underscore faces underscore and div, like that. And make sure mesh and ot are in all caps. And now type in equals and then open and close curly braces, and then inside of the curly braces type in mirror, like that, in double quotations, and then colon, and then type false with uppercase F. So after that, we are going to hit enter again, and then we're going to type in transform underscore ot underscore shrink underscore flatten is equal to open curly braces and then enter an indent, and it's going to be like a dictionary now. So we're going to type in value in double quotations, and we're going to say colon, and then we're going to say 1.4. So now we can just type the close curly braces and then the close parentheses. So this is pretty much just going to extrude our mesh, as you can see, and then enter a few times and then shift tab a few times to unindent, and let's continue. So now we're going to go ahead and type in bm.faces.ensure underscore lookup underscore table, open and close parentheses again, because we just extruded and we like added new geometry, so we have to do that. And now let's hit enter a few more times for spacing, and let's type in for v in bm.verts, and then a colon, then enter and type in if v.select, and then colon again, and then type in enter and then v.co.z minus equals 0.1. Let's go ahead and hit enter a few more times, shift tab to unindent, and now let's type in bpy.ops.edit mode underscore toggle, open and close parentheses, to like tap back into object mode. So now let's go ahead and hit enter, and let's type in obj.rotation underscore Euler, and then open and close brackets, and then inside of brackets let's type in 1, and then let's type in plus equals 3.14, which is 180 degrees in radians. And then once again, if you're confused on all this, don't worry, I'll be explaining all this once we're done. So now we're going to go ahead and type in bpy.ops.object.shade underscore smooth, and then open and close parentheses. And now we're going to type in subdiv underscore modifier is equal to obj.modifiers.new, and then open and close parentheses. And then inside we're going to pass in a few parameters, and the first one is going to be subdivision in double quotes and then comma, and then we're going to type in subserve as shown on screen in single quotes, which is an ID name, so it has to be exact. And now we're going to hit enter a few more times, and we're going to type in subdiv underscore modifier dot levels is equal to 2. So now once again let's hit enter a few more times, and now we're going to type out displacement underscore modifier equal to obj.modifiers.new, and then open and close parentheses, and then once again we're going to pass in 2 parameters inside of the parentheses. In double quotes we're going to type in displacement comma, and then in single quotes we're going to pass in displace in all caps. Let's hit enter again, and this time we're going to say texture1, the variable texture1, and we're going to assign it to bpy.data.textures.new, and then open and close parentheses, and pass in 2 parameters. We're going to pass in the first parameter, it's going to be texture1 with uppercase T and then comma, and then in single quotes we're going to type in clouds in all caps. And now we're going to hit enter and type in texture 1.noise underscore scale is equal to 1.5. Now let's hit enter again and type in displacement underscore modifier texture is equal to texture 1. I hit enter a few times and type in bpy.ops.object.modifier underscore apply, and then open and close parentheses, and inside the parentheses we're going to type in modifier is equal to, and then double quotes, subdivision, which is the name of the subdivision surface modifier if you recall, space again, and then we're going to do the same thing. We can basically just type in bpy.ops.object.modifier underscore apply, and then open and close parentheses, we can type in modifier is equal to, and then in this case it's going to be displacement, since that's the name of our displacement modifier. Okay, so just hit enter a few more times, and we're going to say bpy.ops.object.volume underscore add, open and close parentheses, and now we're going to go ahead and type in v is equal to bpy.context.collection.objects, and then we're going to type open and close brackets, and inside of the brackets we're going to type in -1, and basically we're just going to do the same thing. We can just control C, control V, copy and paste this line and say cloud instead of V, and then bpy.context.collection.objects, and instead it's going to be -2. So this is basically, we're assigning our cloud mesh to the second to last object in our collection, and the volume to the last object that we added in our collection. And if you see, this line is basically adding a volume, so this automatically becomes the last object on our collection. So now we can basically just hit enter a few more times, and we can say v.name is equal to, and then in double quotations, cloud volume, and then we're going to say cloud.name is equal to, in double quotations we can type in cloud. And now we're going to hit enter a few more times for spacing and type in v.modifiers.new, and then open and close parentheses, and we are going to type in two parameters, and the first one is going to be mesh to volume exactly as shown in double quotations, and then another parameter, so comma, and then in single quotes we're going to type in mesh underscore to underscore volume in all caps, because remember this is an identifier and this has to be the exact same. So now we're going to hit enter again and type in v.modifiers, and then open and close brackets, and inside of the brackets we're going to type in double quotations mesh to volume, just like we did up here, and then we're going to make sure the name is the same name, of course, and then we're going to say dot object is equal to, we can say cloud because we assigned cloud to the second to last object on our collection, so that would work. What we're going to do now is say v.modifiers, and then open and close brackets, and then once again mesh to volume, just like we did before, and now we're going to type in .voxel underscore amount is equal to 128. So now that we're done with the modifier, we can move on to the material for our cube, which is the cloud. Let's hit enter a few times, just like we did here for spacing, and we're going to type out cube underscore mat is equal to bpy.data.materials.new, and then open and close parentheses, and we're going to say inside of these parentheses we can type in name is equal to, and then in double quotes, cube mat with uppercase C and M in double quotes as shown. So now we can enter a few more times and type in cloud for cloud mesh .data .materials .append, and then open and close parentheses, and we can say cube underscore mat just like that because it's the name of their variable that represents the material. So we can hit enter. Once again, say cube underscore mat dot use underscore nodes is equal to true with uppercase T. So once again, enter a few more times and say principled underscore BSDF is equal to cube underscore mat dot node underscore tree dot nodes dot new, and then we can open and close parentheses, and we can say shader node BSDF principled. There we go. And make sure S and then B and P are capitalized because it's an ID name. Hit enter a few more times and say cube underscore mat dot node underscore tree dot links dot new, open and close parentheses, and we're going to say principled underscore BSDF dot outputs open and close brackets, and we're going to type in 0, then comma, and then we're going to type in cube underscore mat dot node underscore tree dot nodes, and then open and close brackets, and then inside we're going to type in material output exactly as shown, and then dot inputs, open and close brackets, we're going to type in once again 0. So that's pretty much it for that one. Enter a few more times again, and let's say principled underscore BSDF dot inputs, open and close brackets, and we're going to type in 21. And then we're going to type in dot default underscore value is equal to 0. So finally, let's just remove the existing principled volume shader, and let's hit enter and type in principled underscore volume is equal to, and then we're going to say cube underscore mat dot node underscore tree dot nodes again, and we're going to say dot get instead, and then open and close parentheses. And then inside of the open and close parentheses, we are going to type in principled volume in quotes, and we're going to type out cube underscore mat dot node underscore tree dot nodes dot remove, open and close parentheses, and now we're going to type in the variable which is principled underscore volume. And type enter a few more times, and we are going to type in obj dot hide underscore render is equal to true. Now remember, object is the context object, and since we were just editing the cube, the mesh for the cube, then the cube became the active object instead of the volume. So now we can type in v.modifiers, open and close brackets. We're going to say mesh to volume in quotes, and then we're going to say dot density is equal to 2.5, or actually let's do 3. So now once again, let's hit enter a few more times and type in vd is equal to v.modifiers new, and then open and close parentheses, and now we're going to pass in 2 parameters. The first one is going to be volume, displace in double quotes with uppercase V and D, and then comma, and then in single quotes we're going to type in volume underscore displace, all caps. So now we're going to go ahead and hit enter a few more times and type in texture2 is equal to bpy dot data dot textures dot new, open and close parentheses, and now we're going to type in texture2 with uppercase T, and then comma, and now as an identifier we're going to type in clouds in single quotes and all caps. So enter a few more times, and then we're going to type in texture2 dot noise underscore scale is equal to 0.9. So now let's hit enter again and type in vd dot texture is equal to texture2. So this is like a quicker way to assign a texture to a modifier. So now let's hit enter once again, and let's type vd.string is equal to 3. Alright, enter again, and now we're going to create a material. So v underscore mat is equal to bpy dot data dot materials dot new, open and close parentheses. First parameter is going to be the name, which is going to be equal to cloud. So this is going to be the name of our volume material. So now let's hit enter a few more times and type in v.data.materials.append, open and close parentheses, and we're going to pass in v underscore mat, just the variable name with no quotations or anything like that. So now we're going to say v underscore mat dot use underscore nodes is equal to true with uppercase T. Enter a few more times, and let's say v underscore mat dot node underscore tree dot nodes, and then we can type in open and close brackets, and then inside of the brackets in double quotations we can type in principled volume as shown, and then dot inputs, and then open and close brackets. Inside of the inputs we're going to type in 4, and then dot default underscore value is equal to 0.075. So don't worry guys, we're almost done here. So now let's hit enter a few more times, and let's type in cloud for the cloud mesh dot scale is equal to, and this is going to be a 3 value tuple inside of these open and close parentheses. So what we're going to be typing first is random dot uniform, open and close parentheses, and we're going to say 1, comma 5 inside of these parentheses. Then let's say comma, and for the second one, let's say it's pretty much the same thing. So random dot uniform, open and close parentheses, and once again we're going to type in 1, comma 5. For the third one, it's going to be random dot uniform, and then instead of 1, comma 5, it's going to be 1, comma 3. So now we're going to say cloud dot location is equal to opening close parentheses, and now inside of these parentheses we are going to essentially say random dot rand int and opening close parentheses, and it's going to be 1, comma 50 instead. For the second one, it's pretty much the same, so random dot rand int and then opening close parentheses 1, comma 50. And then for the third one, it's going to be random dot rand int, and then instead of 1, comma 50, let's say 10, comma 20. Alright, so for the final line, we can just hit enter a few more times, and let's say bm.free, open close parentheses, and this is going to free the bmesh data. Alright, so finally, let's go ahead and type return, and then open and close curly braces, and inside these curly braces, we're going to type in the single quotes, and then we're going to say finished in all caps. Before we define our register function, let's go ahead and fill in the blanks for our operator up in our panel draw function. So as you can see, we have the open and close parentheses inside the operator. So, but if we scroll right down here, we have our bl_id name of the operator. So we can just copy this with the quotations and everything, and we're going to say Control C, and then we're going to paste it into the row.operator. Let's type in comma, and let's add an icon. So if you don't have the icon viewer add-on, as you can see, I don't have it. So let's go ahead and go over to edit, then just go to preferences, add-ons, and search for icon viewer, and then just enable it. And I'm going to save my preferences because I'm going to want it there. So now let's just hit the icon viewer button, and as you can see, it brought up a window in which you can choose a bunch of icons. So in this case, we can type in something like cloud, and this is a pretty logical icon for what we're looking for, I guess. So as you can see, to the right of the search bar, we have kind of like whenever we click an icon, an ID name is going to pop up. So we're just going to click on it and then Control C, and then we're going to hit OK, and then we're going to type in comma if we haven't already done so, then icon is equal to, and then in single quotes, just paste the ID name. So now let's scroll all the way back down, and we're going to define our register functions. Shift tab a few times to unindent, and now we're going to say, we're actually going to put all of the names of our classes inside a classes list. So we're going to type in classes is equal to open and close brackets, and inside of the brackets we're going to type in, basically we can just go up and then copy the name of our classes. So let's first start with the properties, paste it, comma, then just go to your panel, Control C, and then just paste it, and then comma once again, and then just the operator, Control C, and then paste it, and there we go. We have a list of 3 items, which are the classes. So now we can basically just go ahead and say df register, open and close parentheses, and then colon for our register class. And now we can just go ahead and hit enter and say for CLS in classes. Basically, CLS can be anything you want. If you want, you can literally just change this to object or class or whatever, but just keep in mind that CLS represents everything inside of this list. So we're going to go ahead and type in colon, then enter, and we are going to say bpy.utils.register_class, open and close parentheses, and then inside the parentheses we're going to type in CLS. We are going to shift tab, basically say bpy.types.scene with uppercase s .cloud_gen, which this can basically be whatever you want, and then we're going to type in equals pointer property with uppercase P and then another uppercase P, and then we're going to say open and close parentheses, and then type is equal to, and then the name of your properties class. In this case, we can just copy this one, and then we can just paste it. And actually, let's just indent it inside of the for loop. Enter a few more times, shift tab to unindent, and now we're going to say df unregister, open and close parentheses, and then colon, and then we're going to do the same thing. So for CLS in classes, colon, and then enter bpy.utils.unregister_class, and then inside the parentheses we're going to type in CLS. So now we're going to say, right after hitting enter, we're going to say DL bpy.types.scene.cloud_gen. So every time it registers the class, it adds this pointer property. Every time it unregisters it, it adds this, it deletes it, basically. Just hit enter, shift tab to unindent, and we're going to say if underscore underscore name underscore underscore is equals with two equal signs, and then the quotations, and then inside the quotations underscore underscore main, and then underscore underscore again, and then colon. We're going to say register, and then open and close parentheses. Make sure you have two equal signs and that there's two underscores on each side of these variable names. So now we are pretty much done with the script, so don't worry if you're intimidated. I'll go ahead and explain everything. So let's go up to the top, and you'll see that first we have our BL underscore info dictionary, which basically just defines information about our add-ons. So we have the name, the author, the version, the Blender version, and then the location, the description of the add-on, and then some warnings, and then some documents, and the category. And then we have the modules, which is, we have BPY, which is Blender Python, BMesh, which I sometimes prefer working with because of its ease of use, and then we have the BPY properties, and we also have random. Well, we have this properties class, which basically just has a bunch of properties that we can use, such as density, anisotropy, and color, and it is a property group. Moving on down, we have our panel class, which has panel as an argument, meaning it's a panel, and this one has a label, which is the label of the class, the ID name, which is unique to this class, space type, and region type, which tell Blender where it is, and category, which is how it's going to show up on our end panel. This is our draw function, which essentially just draws all the elements in our panel. So up till now we have two rows, and then a label, and then an operator, which is the button. Moving on down, we have the operator class, and as you can see, we have the type of it being an operator passes in as an argument, and then a tooltip, which tells us stuff about the operator when we hover over it. And then we basically have a label, which is the label of the button, the ID name, which once again is unique to the operator, and we can use to point to the operator with buttons in UI elements. And then we have options, which lets us use undo and redo. Additionally, we have our execute function, which has two parameters, self being itself, and then context being the context of what's going on. First line is simply adding a cube. The second line and third line is basically assigning the obj variable to the active object and then toggling into edit mode. This one is basically, as you can see, I'm opening my hash key, typing in my hash key, and saying creating bmesh object. And then this is basically to make sure that indexing works fine. And then this is basically checking for the faces, make sure they're deselected. This is basically selecting the faces at index 0, 2, and 4, which is essentially the top and the two side faces. And then we have the update line, which basically just updates the mesh before we extrude. And then this line basically just extrudes. So this whole chunk of code basically is just an extrusion for 1.4 meters for the faces that we selected. This basically just moves our vertices by negative 0.1 meters. This once again is just for the indexing, so yeah, I explained that earlier. And then we have toggle back into object mode. This one toggles back into object mode, and then this line basically just sets the rotation of the cloud mesh. And then this one basically sets shade smooth. And then these are basically subdiv modifier. You're adding the subdivision surface modifier, and this is just increasing the levels. And let's make sure to specify its viewport. And then you're also adding a displacement modifier, and we are assigning a new texture, and then changing the noise scale, and then we're basically assigning the texture to the displacement. So assigning texture, we can just do that. And then this is basically applying the modifiers, and it's the same for both of them, so we can just use one comment for that. So this line adds a volume. So with this line of code, we're adding a new volume to our scene. This is assigning variables for our objects. So the first one is v, and then we're assigning this to this collection object at index -1, and it is the last object, meaning the final object that we added, meaning it's this, and then cloud to the second to last object we added, which was, if you remember, our cube. So then we change the name of our meshes or objects. Then we add some modifiers to the volume. This is the mesh to volume modifier. We basically make the target object to our cloud mesh. And then we basically here we just change the voxel amount. So increase quality, we can say. And then we're creating a new material for our mesh. So creating new cloud material. And then appending it, which is basically just like make sure that the cloud mesh has this new material. This is basically for use nodes, so that's pretty self-explanatory. We can say on this one we can say add principled BSDF, and then this one is just creates a link between principled shader and material output. This one is basically assigning the alpha to 0, which is the 21st input of the principled shader. This one is essentially getting principled volume, and this line is removing principled volume. This line hides active object from render, which is, in this case, the cloud. We don't want to see that in our render. This one is changing the density of the mesh to volume modifier. This one is adding a volume displays modifier to our volume. This is making a new texture, changing its scale, and assigning it. This is the string of the modifier, and this is a new volume material. This is basically assigning the material to our volume. This is for use nodes, and then this is basically an anisotropic, however you pronounce that, to 0.075. So we're changing the anisotropic value to a hard-coded 0.075 value. And these lines basically just change the scale to a random number, and then we can just copy this and then just paste it here, and then just change this to location. So random.uniform is a decimal between 1 and 5, and rand_int is an integer between 1 and 50. So just something to keep in mind, and this is basically just getting rid of bmesh data. And one more thing I'd like to say about the scale is that the first value represents the x-axis, the second value represents the y-axis, and the third one the z-axis. And it's the same case for these three as well. One last thing we have to do is we are going to be creating the long-awaited functions for our density properties, which I was talking about earlier. So now we're going to go ahead and create, the first one we're going to create is probably for the anisotropic. So let's say df update underscore anisotropy. Say open and close parentheses, and then inside those parentheses we're going to type in self, comma, context. So now we're going to go ahead and hit colon, enter, and then we are essentially going to be saying obj is equal to bpy.context.active underscore object. So assigning the active object to the obj variable. And now we're going to say cloud underscore mat is equal to bpy.context, or we can actually just say object dot active underscore material, if I recall. And then we can hit enter and say pv is equal to cloud underscore mat dot node underscore tree dot nodes dot get, and then open close parentheses, and inside the parentheses we can type in principled volume. just like that, and then with double quotations, and now enter, and now we're going to say if cloud underscore mat, and then colon, and then we're going to say pv dot inputs, make sure that's a dot, yes, dot inputs, open and close brackets, and inside the brackets we are going to be typing in 4, and then we're going to say dot default underscore value is equal to self dot anisotropy. Alright, let's go ahead and make our density function, which is probably even simpler. We can just say df update underscore density, like we said here, and then we can say open and close parentheses and self comma context, and then colon, enter, and then we can say obj is equal to bpy.context.active underscore object, just like we did up here in our anisotropy function, and then simply hit enter, and literally all we have to do is if obj.type, meaning if the type of the object is a certain type. In this case, we're going to check for volume, so equals equals, and then in single quotes, volume in all caps. We're going to hit colon, enter, and then we're going to say obj.modifiers, and then open and close brackets, and then inside we're going to say mesh to volume, exactly as shown, dot density is equal to self dot density. Alright, so that should work. That's pretty much all for the density function. So for the anisotropy function, for the color function, which is the last one, it's pretty much the same as anisotropy. So we can say def update underscore anisotropy, open close parentheses, self context, just like we did up here, and then enter, and then we can type in obj is equal to bpy.context.active underscore object, and then we can say v underscore mat is equal to obj dot active underscore material, and now we can say pv is equal to v underscore mat dot node underscore tree dot nodes dot get, open close parentheses. Inside the parentheses we can type in principled volume as shown, and now we can essentially say the same thing. So like if v underscore mat and then colon and then enter, pv dot inputs, open and close brackets, and then we can type in 0 inside, and then we can say dot default underscore value is equal to self dot color. So just to clarify, if we didn't have these functions, then if we changed our properties on our panel, it wouldn't update in real time. So these update functions help us update our properties that we're going to change in real time on our panel. So lastly, let's go ahead and add the props on our panel. So I think this might actually look even better if we put them in like a bots. So let's say bots is equal to layout.bots, open and close parentheses, and we can type in bots.prop, open and close parentheses, and we can type in, actually, before we proceed, up here on our draw function, we can type in scene is equal to context.scene. Actually, let's put this, Control C, let's put this below our layout. So scene is equal to context.scene, and then cloud underscore gen is equal to scene dot cloud underscore gen. So now we can say cloud underscore gen and then comma, and then in double quotes the name of our first property. So let's do anisotropy for our first one, anisotropy. We can just type that in there, and let's go ahead and copy the scene and then cloud gen variable down here in our execute function, as we're going to use that in a bit. So now let's go ahead and copy and paste this bots.prop 2 more times, and we're going to change this to density and change this last one to color. Alright, so in order for Blender to recognize that we're changing those sliders for the specific values, then we are going to have to go ahead and change some of these hard-coded values to the value that is of the property. So essentially, let's go ahead and look for density first. So this is the density. So let's go ahead and change that to cloud underscore gen dot density, meaning cloud underscore gen, the properties, and then density which is the specific property that we're accessing. So let's go ahead and go over to here to the anisotropy and change that to cloud underscore gen dot anisotropy. And then lastly, we can make a new line for color. So we can literally just make a comment here for color, and then just copy this entire line, and then Control C, and then we can paste it here. And then we can say inputs 0 instead of inputs 4, and then we can change this cloudgen.anisotropy to cloudgen.color. And I think that should work properly. Okay, so before you run your script, I had just run my script and I realized a lot of stuff happened. So make sure that update is underscore color is written properly here as update underscore color and not update underscore anisotropy. Okay, that was a mistake I made. Make sure all your naming is okay, so make sure float vector property is properly named. Make sure that, and right here we made an object, an error when writing the slime, so it has to be by.ops.object.editMode underscore toggle instead of .editMode underscore toggle directly. So I think that should pretty much do it. So if you just say run and then just hit N, we have our new cloud adder panel. So let's try testing it out. So we change our render engine to cycles. Let's turn on denoise, and we can do generate, and you can see it generated a new cloud. If we hit generate again, it's just gonna create some more clouds. Awesome. Okay, so go ahead and zoom out. These are pretty high up on the z-axis, so, and they're pretty big too. So let's go ahead and say rendered view. Go over to our world properties. Go ahead and increase this something like that. Add a freaking sunlight. Move this like that. And then the strength to 15. So that way you have some nice looking lights or whatever. And they're like light looking clouds. So let's go to our CloudGen panel by hitting N and then going over to the CloudGen category. And let's try to mess with some of these. So let's change the density on this one to something like, I don't know, something like really low, like 0.42. You can see how it changed the density a lot, and maybe the color to something like a dark black or something. See that? That looks nice. It looks like I don't know. Let's go ahead and change the anisotropy to something pretty dark here. I'll put up the technical definition of anisotropy on screen, but essentially like in this cloud add-on it makes them like kind of like darker, sort of. And we can also change the color to something, actually let's try changing it to like blue, and then we can do like green on this one. I absolutely hate colored clouds like that. But you can just mess with these values as much as you want and get the results that you are expecting. And of course the things you do depend on your needs and your wants. So yeah, this is the fun part where you mess around with your clouds. So go ahead and mess around with your newly created add-on as much as you want. By the way, to move your clouds, you don't move the volume. You select your mesh. So if you know you're selecting your volume, it's because it has like an outline. But if you're selecting your mesh, it has like an outline around your mesh. So I'm just trying to select. Okay, there it is. Oh, there it is. Okay. So now if you hit G, we can move the cloud around. Sorry for the lag, but we're in rendered view, and you know how it is with Max. And then you can just move it around however you want. We can just place it here if we wanted to. And also, these values down here, like, if you think 10 is too low, like, just change that to, like, I don't know, 50 or 100 or whatever. Like, this is a minimum and maximum. It's like a range of this number and this number. So just change that, like, to whatever you want. Maybe experiment with some of these values. Maybe add some more properties if you want, depending on what you really are looking for or are needing. So actually, let's just change this color back to something logical. Wait, no, I meant to change it on here. So, there we go. Okay, so one last thing before we end the tutorial. So you're going to go back to your scripting tab up here, and you are going to go ahead and rename this to cloudgen.py. right? So now you have a .py script, which is a Python file. So now you go over here to where it says text. You go down here to save as, and then you just save it on probably like your desktop, and then just hit save. And then basically you can literally just like go to your layout maybe, and then just get rid of all these clouds to start with. And then just go to edit, preferences, and then just go to add-ons, and then just hit install, and then go to desktop, and then select your script, and then install add-on, and then just hit like the checkbox, and then just go save preferences, and then your script is gonna show up on your end panel every time you open Blender. So yeah. So now we can pretty much just hit generate, and it'll basically just do that. Anyway, so thank you guys so much for sticking around with me all the way to the end and watching this tutorial. It means a lot to me. If you want, you can go ahead and send me your results on Instagram. If you have any more questions, or if you just want to show me what you did, then please feel free to reach out to me and send me, because I would love to see what you guys come up with. And you can see, once again, as I mentioned earlier, this panel only has like 2 properties, but you can change, you can add more, like with our workflow that I showed you. And it's pretty much the same thing. You just kind of have to, I don't know, mess around, figure out, maybe with your info window that tells you like the values you edit. So like, for example, you can like just go to your volume and then change something on there, maybe the material. And then just like, I don't know, if you want to change like, I don't know, the emission strength to something like that, and you'll see on your info window down here, you'll see the code for it, so you can change it, and you can add even more properties. So yeah, if you guys have any more questions or suggestions down in the comments, or have any issues, I'm reading all those comments, I'm taking requests for future tutorial suggestions, and please do not hesitate to let me know. So once again, I appreciate all your support. Thank you guys so much for sticking around, and God bless you all. Bye bye.